Okay, so I'm going to go over a quick recap of quiz 7 and quiz 8 with the ionic compounds. Uh, Show you how to do them. All right. So here's a list of them. So this combines quiz 7 and quiz 8. All right, there they all are, and we'll go over each one of them. So we'll do the names first of the I believe this is quiz 7. So you give it Mg3P2. Okay, naming is always easy. It's always just going to be the metal and the non-metal. It's binary, so ends in "ide." So magnesium phosphide. You don't have to say tri-magnesium diphosphide. It's simply magnesium phosphide. Okay, so binary. Binaries end in "ide." Okay, this guy here, it's ionic. We know that because it has a metal in it and non-metal. It has three elements. It has calcium, phosphorus, and oxygen. And this thing is a polyatomic ion. So all ionic compounds just get two names. So it's going to be calcium phosphate. Okay. And one thing I want to make sure you get is, I'll go over this on the last slide, is that phosphate and phosphide are a lot alike, but they're different. Okay. So if you see 8, it's tertiary. Okay, ALN. So we have aluminum. It's binary, so it's just going to be aluminum nitride. Okay, so aluminum nitride. This A, KNO3. All right, so it's tertiary ionic, has 3 elements, and it's ionic because it has potassium. So it has, so it's a metal plus a polyatomic, and this is nitrate. So it's potassium nitrate. And the last one, silver and phosphate. It's again, it's ionic because it's silver. Tertiary because it has 3 elements. It has silver, phosphorus, and oxygen, and this PO4 is phosphate, so it's silver phosphate. Okay, don't make these hard. So you just have to first of all determine if it's binary or it's ionic. Then binary or tertiary, if it's binary, it ends in "ide. And if tertiary, it usually ends at 8, except when we have hydroxide. Right, so now let's go the other way, where you give it a name and go to the formula. And this is more difficult. So what you do is you write out each. So we know that this is a binary because it's ends in "ide. So it's just going to be the 2 elements, magnesium and nitrogen. Now you have to know the charges, okay? Everything in the second row is 2 plus, and nitrogen is in the 15th column. So everything in that column gets 3 minus, okay? So you have your charges, you have it. And so what you're going to do now, if the numbers are different, you crisscross, and then you get this, okay? And you can leave it like this. I actually prefer it like this, but you can write it like this. I will prefer the charges, especially when we get into the next test material. So it's Mg3N2. And you can check the name, magnesium nitrate. And that's what you got over here. Okay, next one, potassium sulfate. Write down what you have, K plus. Okay, this is a polyatomic sulfate. What I do is I like to put them in parentheses or circles. That way, you just want to treat this as a whole thing, okay? So like it's element, like something with the 2 minus charge, okay? So don't let this thing in the middle get in your way. So it's just going to be, and then what you do is you crisscross charges because they're different. So you put the 2 over here and the 1 over here, and so you end up with K2 SO4. And if you want, you could have a 1 here, okay? And then if you want to just get rid of the charges, you can get this, and if you want to get rid of the parentheses, you'll get this. Okay, I'll take any one of these here as the answer. All right, and again, I'll prefer this answer here eventually. Okay, next one is barium sulfide. So it's binary, so it's going to have barium and sulfur in it. Okay, barium's the second row, it's 2 plus. Sulfur is in row 16. So I mean column 16, so it gets 2 minus. Okay, they have the same charges, so you don't have to crisscross. So it's going to be Ba2 plus, 2 minus. And without the charges, you get this here, BAS. Right, and the last one, iron carbonate, and this one really got people mixed up. I don't know why. I told you guys it's Fe3 plus. I don't know if you're just looking on the internet or whatever. So iron is Fe3 plus. You have to memorize. It can be Fe2 plus, but we're not doing that. All right, we're keeping it Fe3 plus for a reason right now. Right. So iron carbonate. So this, it has 8 in it, so I know it has a polyatomic, and it's carbonate. So it has iron 3 plus. Okay, carbonate, CO3 2 minus. Again, I'm going to leave the polyatomic in parentheses in a circle, and then we just swap the charges, 3 here and 2 here. So now you get 2 here and 3 here. And if you don't like the it's not if you don't like, but if without the charge you can have this here. Okay. Now you have to leave the parentheses now, because if you take the parentheses out, right, Fe 2 CO3 3, it looks like there's 33 oxygens. Okay, so you don't want to do that. So you want to leave it, leave the parentheses on here. If there's just one of them, like up here, you can remove the parentheses. Okay, let's go to the next batch. Okay, the next batch, you have sodium hydroxide. So this is, looks like it might be binary because it ends in "ide." But remember, hydroxide is a special case of polyatomic. It ends in "ide" instead of 8. So you just write Na plus, first column, and OH has a minus charge. They have the same number in front. They have a 1 plus and a 1 minus. So the number is the same, so you don't have to crisscross. You get this answer. Or if you take the charges out, you get this. And because there's just one of the OH, you can just write it NaOH. Okay, zinc nitrate. Okay, it's tertiary because it ends in 8, so you'll have nitrate. And that nitrate is NO3 with a minus charge up here. And zinc is 2 plus, and it's one of the ones you have to memorize. Okay, the charges are different, so you can crisscross, put a 2 down here, and a 1 down here. Of course, you can leave that off. And so you get this and this, okay? Zinc nitrate. And so if you leave the charges off, you get simply this. Lead bromide. Okay, this is binary because it ends in "ide." So lead is one you have to memorize. Bromine is in the 17th column because it's minus. Crisscross charges, 2 and 1. So here you go. So there's 2 BRs and 1 BP. And if you remove the charges, you get BR2. Okay, sodium chloride. Again, it's binary because it ends in "ide." So you have Na plus, Cl minus, first column, 17th column. Don't have to crisscross, remove the charge. You can, but again, I prefer with a charge. Magnesium sulfide, again, binary. So magnesium has a 2 plus charge, second column. Sulfide has a 2 minus charge, 16th column. Right, and then they have the same charge, so you don't have to crisscross, and you get MgS. All right, so let's go over the next set. So aluminum nitride, okay, it's binary, ends in "ide." So it's just two elements, aluminum, you have to know that. Nitride, nitrogen has a 3 minus charge, it's in the 15th column. They have the same charges, so they cancel out. I mean, not cancel out, but they equal, so you don't have to crisscross, and so you can just write Al 3 plus and 3 minus, or ALN. Beryllium phosphate, so it's beryllium, it has a 2 plus, second column, phosphate, PO4 3 minus, crisscross, 2 and then a 3. Okay, and then if you don't want to put the charges on, you'll get this. Right, silver carbonate, we know it's tertiary because it ends in 8. So that's silver. That's one you have to memorize. First, remember, the first two columns are going to be +1 and +2, and then you had 6 you had to memorize. Carbonate is CO3 2 minus. So crisscross charge, bring a 2 here and a 1 over here, so you get Ag2 CO3. Without the charges, you get these. Again, if you just have one of these, you don't have to have the parentheses. But if you have more than one, you definitely need. Like here, you'd have to leave the parentheses. Here, you don't. All right, calcium sulfate, again, it's tertiary ionic because it ends in 8. So calcium second column, sulfate, SO4 2 minus. They have the same charge, so you don't have to crisscross. So you end up with this with the charges, and both of these. Any one of these three will be okay. But I said I prefer this one when we go to the next material. Okay, magnesium hydroxide. Okay, so this ends in "ide", so you might think it's binary, but it's hydroxide, so it's the weird guy. So it's OH minus. Charges are different, so you can put a 2 here and a 1 over here, so you get Mg2 plus OH minus 2. And then MgOH. Okay, I see a lot of students doing this. MgOH2. Okay. If there's more than one of the polyatomic, you have to have it in parentheses. Okay. If you have it without parentheses, it's wrong. All right, and finally, the again names, the formula name. So this is ionic. This is binary because it has just 2 elements. So you just tell who's in it. Iron carbide. Again, binary because it only has 2 elements. Lead chloride. Again, binary. Sodium sulfide. Okay, tertiary because it has 3 elements. Iron, copper, and oxygen. This guy here is carbonate, so it's iron carbonate. And then BeNO3 is tertiary. It has nitrate in it, so it's barium nitrate. Okay, next one is also tertiary. It has 3 elements: cesium, carbon, and oxygen. This is polyatomic. Whenever it's tertiary, it has a polyatomic, so it's going to be cesium carbonate. Next one, 2 elements, binary, zinc fluoride, and the last one, aluminum sulfate. All right. Okay, hopefully that's getting clearer if you haven't got it already. Okay, some things to keep aware of when you go through these, especially when we get to test 2. Okay, sulfide and sulfate obviously sound a lot alike. They both have sulfur in them. They're different. Ide means it's a single element. 8 tells me that it's polyatomic. Notice they both have 2 minus, 2 minus. So they're kind of tricky because of that, because they both have S and a 2 minus. So keep this, keep this in mind. I will, on the next material, maybe in this test, you'll see sulfate. Yeah, so I'll say magnesium sulfide, and you'll write down S. Don't do that. Okay, pay attention. Same thing goes with phosphide and phosphate. Okay, they both have P in them, and notice they both have a 3 minus charge. So that can be tricky. So pay attention to the 8 and the ide. Now, nitride nitrate are a little bit different, but they can be kind of tricky as well, because they both have N in them, and they both have a 3. But where the 3 is important here. This is nitride is 3 minus. Nitrate is NO3 with a minus charge. Okay. So just to let you know when you have a minus charge like nitrate. So when you say NO3 minus, really what it means is that there's a minus not on the oxygen but on this whole molecule. There's an extra electron than if there was this NO3 and NO3 minus are different because NO3 has an extra electron on it versus, so this has an extra electron. That's what the negative charge means. Okay, so that's when you see NO3 minus, it means the whole thing with a minus charge. SO4, 2 minus, is different than SO4 because this whole thing has 2 extra electrons compared to this guy over here. Now this guy is called sulfate. This one would be called sulfur. Tetra. It's a binary oxide. It's a binary covalent. Okay. And I should go over that real quickly as well. I'll throw that at the end of this one as well. Okay, also sodium, silver, and sulfur get kind of mixed up. It looks like sodium starts with S, and so sometimes people put S as its chemical symbol. Same thing with silver. And same thing with potassium. Okay. Okay, the last thing, I want to go over a little bit about the covalence. Let's say you're given a covalent name or formula, and you want to determine what it is. Okay. Now, the way that let's say I start out with CS2. I want to come up. I want to know its name, and I also know what type it is. Okay. So when I say type, I mean it's gonna. Some of you put polar, covalent, bonds. Okay. So when I asked on, I believe it's quiz number 6, give me the name or formula and the type, I mean it's one of these guys, okay? So let's go over this one. Let's say I give you CS2 and I want to know its name and what type, okay? So actually what I'm doing is I'm going to figure out the type first. So so what I do is I go in this order. I go, first of all, I ask myself, is it one of the commons? All right, so there's 5 of those, and it's not. There's water, hydrogen peroxide, ammonia, glucose, and vinegar. Okay, then you ask yourself, is it an alkane? Okay, well, alkanes just have carbons and hydrogens, so no, this is not alkane. Right, then you ask yourself, is it a polyatomic? Well, polyatomics have oxygens and a negative charge, so no. Is it an acid? No, because they start with have an H in front. So it's got to be, just by default, it's got to be binary. Okay, and binaries, the way that you name them, you use prefixes. So this guy here, the first element, if there's one of them, you don't have to say mono. So this guy is just going to be carbon disulfide. Okay, sorry about my right ear. Carbon disulfide. Right now, let's go to CH4. Okay, so go through the list. Is it a common? No, it's not one of those 5. Is it alkane? Yes. It has carbons and hydrogens in it. So it's got to be one of the 10, and it's methane. Right, HCl. Okay, HCl, again, you go through the list and check if it's common. No. Is it alkane? No. Is it polyatomic? No, it doesn't have a charge and oxygen. Is it acid? Yes. Now what you have to do with the acids is be specific. You got to tell me if it's binary or tertiary. This is binary, it just has 2 elements in it, and it's hydrochloric acid. All right. Okay, the last one here, P2F3. Is it common? No, it's not one of the 5. It's not alkane because it doesn't have C and H. It's not a polyatomic. Okay, polyatomic one. It kind of looks like PO4 2 minus 3 minus, but it's not. So it's not polyatomic. They have to have a minus charge in them. It's not acid because it doesn't start with H, so it's got to be binary. Okay, so this one that has a 2 of these, so this would be diphosphorus. I won't write that out. Diphosphorus trifluoride. Know your prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. All right, now let's go the other way. Given the name formula, so heptane, okay, Is it a common? No, it's not 185. Is it alkane? Yes, because it has ane in it. All right. Phosphate, is it common? No. Alkane? No. Polyatomic? Yes. They all end in 8 except for hydroxide. PO4 3 minus. Okay, dinitrogen monochloride. All right. Not common, not alkane, not polyatomic, not acid, binary. Another way you can tell it's binary because it uses prefixes. So this would be N2 Cl. Don't put any charges on it. Don't put a minus or pluses. Okay, it's just simply N2Cl. Okay, the last one, sulfur trioxide. Okay, go through it. It's not common, not alkane, not polyatomic, not acid. It's binary. Okay. Another way to tell it because it has prefixes in it. So this guy's, there's just one sulfur and 3 oxygens. Don't put a charge on it. Okay. All right, so that's it.